All right, so this is the second half of 4.1. If you haven't watched the first video, please do that first. I'm just going to label some of these critical points. They don't have to be exact. This is just kind of to get an idea of what we do. So let's say this here is -1, 0. Let's say this here is -2, I don't know, 4. And this here is -3, 0. Okay, down here, let's call this -1, or sorry, +1, -8, I don't know, and this would be 2, 0. So we just had to do that because it's not clearly marked on this graph. All right, so we want to decide by looking at this when our function is increasing, when it is decreasing, when is f of x greater than 0, and when is f of x less than 0. All right, so let's talk about this. Okay, when I say our function is increasing, that means it has a positive slope. Okay, it's going up. When I say it's decreasing, that means it's going down. It has a negative slope. Okay, so as we're increasing, if I look at this here, I'm increasing till I get to here. Okay, and then I'm decreasing. And then from here, I'm increasing, and I can continue to increase forever and ever and ever. Okay, so I could say I'm increasing from -infinity to, my x is 2. Both of these are open brackets because I'm not increasing or decreasing it to. Okay, and I'm increasing from 1 to infinity. Okay, or you could write that as when x is less than -2, I'm increasing, and when x is greater than 1, I'm increasing. I think your book wants this way, but this is what you'll see like in college algebra and things like that. All right, so that means I'm decreasing from here to here, and that's it. So the interval in which I'm decreasing is from -2 to 1. Or if you want to write that as -2 is less than x, which is less than 1. Either of those two are the same thing. All right, now I'm going to erase some of this. All right, so this was -1, 0. All right, so f of x is greater than 0 when. Okay, so now remember that f of x is the same thing as y. Okay, and so this is really saying, when is y greater than 0? Well, remember, y is up and down. So basically, I want to know is when am I above the x-axis? Okay, well, notice I'm above the x-axis from here to here, right? So I'm above the x-axis when -3 is less than x, which is less than -1, or I could write that as -3 to -1. And then I'm above my axis again from here all the way to infinity. So I could say from when x is greater than 2, or in interval notation, I would say 2 to infinity. Okay, so these two are the same thing, and these two are the same thing. Now, when is my y less than 0? Well, I'm less than 0 all right here. Okay, so I would write that either when my x is less than -3, or I could write -infinity to -3. These two are equivalent statements. Or I'm less than 0 right here. Okay, my y value is 0 right there, so I could say from -1 is less than x, which is less than 2. I believe this is how your book wants it, but interval notation would be from -1 to 2. Okay, now by looking at this, use the graph to describe the degree and the leading coefficient. Well, I can tell just by this that it is an odd function, so its degree is odd. Okay, and it has a positive leading coefficient. Okay, and that just goes back to, let me see if I can find it, right here. Okay, all right, so I want you To try to do this one on your own, let's label some points just so we're on the same page. Let's say, for lack of better words, this is 1.5, comma 2. This is, I don't know, 2.25, 0. This is 0.75, 0. Let's let this be -1, -8, and -2, 0. Okay, so let's use those points. I want you to write down, when is it increasing, when is it decreasing, when is your f of x greater than 0, when is it less than 0, and describe the degree and leading coefficient. So go ahead and pause this, try to work that out on your own, and then we'll go over it. All right, this is what you should have gotten. All right, so let's go ahead and sketch this given the specific parameters. So this is example 4. Okay, now I always like to start with when my f of x is greater than or less than 0, because that tells me my intercepts, my x-intercept. So I have an x-intercept at -2, and an x-intercept at 3, and then an x-intercept at 5. Okay, so I'm switching, I'm crossing this x-axis at -2, 3, and 5. Now I'm increasing when x is less than 0, so I'm going up, 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 up until I hit 0. So I'm going to go ahead and draw that here. So up, up, ooh, that's bad. Up until I hit 0, and then when I hit 0, I start decreasing. Okay. Now I decrease until I get to 4, so maybe it's right here, and then I start increasing again. Sorry, didn't quite go through my intercept. There we go, that's a little better. Okay, so my graph would look something like this. It doesn't have to be perfect. Okay, clearly mine isn't. So use the graph to describe the degree. Now our degree is odd. Now we don't know if it's, you know, a degree of 3 or a degree of 5 or a degree of 7. We don't know. All we know is that it's odd, and we know that the leading coefficient is positive. All right, let's look at this last example. It's a word problem. It says the estimated number V in thousands of electric vehicles in use in the United States can be modeled by the polynomial function, and it gives us the equation where t represents the year, t equals 1 corresponding to 2001. So t equals 2 would be 2002, so on and so forth. So part A says use a graphing calculator to graph the function for the interval 1 is less than or equal to t, which is less than or equal to 10. Describe the behavior of this graph on the interval. Okay, so what I did is I took this and this is what I graphed. So I made my window, my x value or my t from 1 to 10. Okay, so that's all I did. I also altered my y window to go up to 100. I'm guessing like 60 would probably be enough if you wanted to change it to that. Yeah, that would be enough too. So it looks something like this. All right, so I'm just going to graph. It looked something like this. All right, so describe the behavior of this graph on this interval. So we're only worried about on this interval. So I'm going to say it went up, leveled off, then up again. So we went up, and then we kind of sort of leveled off, and then we went up again. Okay, so part B says, what is the average rate of change in the number of electric vehicles in use from 2001 to 2010? So average rate of change is another name for slope. Okay, so in order to find the slope, I have to have 2 points. Okay, so in 2001, my x is 1. 2010, my x is 10. So what I'm going to do is I'm going to go back to this, and I'm going to look at the table. Okay, when x is 1, I'm at 18.584. Okay, so 18.584. Okay, and then when my x is 10, so I'm just going to go ahead and type 10 here. I'm at 58.57. All right, so to find the slope between those 2 points, remember slope is y2 minus y1 over x2 minus x1. Okay, so I'm going to say 58.57 minus 18.584 over 10 minus 1. So I got 39.986 over 9. Okay, and if you divide that in your calculator, you get roughly 4.443 is what I got. Okay, and so that would be the average rate, that'd be the slope. So this would be the average number of people per year. Once again, that's the average. Okay, so we're averaging about 4,443 people per year. Okay, so in part C it says, do you think this model could be used for years prior to 2001 and after 2010? I would say no, because not too much before 2001, it goes negative. Can't have a negative population. Okay, and then after 2010, if you zoom this out, it like increases very, very, very rapidly. So I would say no, increases too rapidly.